Hello, and welcome to Math with Usna. In this lesson, we are going to prove that lines are parallel. We'll introduce these types of proofs, as well as some theorems and postulates, and work through some examples. We've got four postulates or theorems here. Corresponding angles, converse, alternate interior angles, converse, alternate exterior angles, converse, and consecutive interior angles, converse. We've had theorems about these angles before. If the lines are parallel, then the corresponding angles are congruent, and so on. We are now going in the opposite direction. If I know something about the corresponding angles, and they happen to be congruent, then the lines are parallel. If the alternate interior angles are congruent, then the lines are parallel, and so on. In these types of proofs, what you're doing is starting off with the angles, and you're trying to prove a relationship so that you can say the lines are parallel. The end goal in these types of proofs is to prove that the lines are parallel. Let's go through an example. Now, I have a separate video that walks through how to do proofs, so if you need a refresher, feel free to check that out. In this statement reason chart, I've already put in my first step, which is the given information. Usually what my next step would be to put in all of my given information to my diagram. However, since I have that angle DBC is supplementary to angle HFE, there isn't a notation that I could put in my diagram, which means I can't do it at all. I would just kind of leave it blank. What I'm going to do is try to figure out essentially a game plan. I want to prove that the lines are parallel, which means I want to prove either corresponding angles, alternate interior or alternate exterior are congruent, or that consecutive interior are supplementary. If I can prove one of those four things, I can say that the lines are parallel. I'm going to put just a little star here and here because these are the two angles I'm talking about so that I'm aware of them. And I'm going to start off by saying that angle DBC is supplementary to angle FBD. Why do I know that they're supplementary? Well, they form a linear pair. We know that if two angles form a linear pair, then they are supplementary. That's the linear pair postulate. So that's my reason. Why did I do that? Because I knew angle DBC and HFE. I had those angles in my given statement. So I wanted to make my next step to correspond with that. I wanted to have one of the angles in my next step match up with one of the angles in step one. And I got that by using angle DBC. So angle DBC is supplementary to angle HFE, and it's supplementary to angle FBD. If I have one angle that's supplementary to both of these angles, then I can say that this angle and this angle are congruent. That's going to be my next step. Angle HFE is congruent to angle FBD. That is by the congruent supplements theorem. And I'm going to put that in my diagram. HFE is congruent to FBD. Notice the types of angles I have here. HFE and FBD, these are corresponding angles. And I just proved that they're congruent. So if I know the corresponding angles are congruent, what does that mean about the lines? It means that the lines are parallel. AD is parallel to GE. And that is the converse of the corresponding angles postulate. When you're doing these types of proofs, you cannot use corresponding angles, alternate interior angles theorem, alternate exterior angles theorem within the body of your proof, because those only work if you know that the lines are parallel. If you're trying to prove that the lines are parallel, you can't use that proof. Remember, when you're working through a proof, you assume the hypothesis and you prove the conclusion. So if you don't know that the hypothesis is true, you can't use it. In these types of proofs, if you don't know that the lines are parallel, you need to think of another way to prove one of those 4 types of angle pairs. Let's try another one. This time we've got 3 lines that are cut by a transversal. MK is parallel to AD. I'll put that in there. Angle BFE is congruent to angle JBD. I want to prove that MK is parallel to GE. I went ahead and already put in my given statements. And now I'm going to go through my given statements and see what conclusions I can make. My first one is that MK is parallel to AD. If those 2 lines are parallel, what do I know? I know a lot of things, but I want to use this angle somehow because it's already touching one of those 2 parallel lines. So this could be essentially like a good jumping point to go from this line to this line. So I want to do this angle somehow. What I can say is that angle CJK is is congruent to angle JBD. And that is because they are corresponding angles. Now, I was allowed to use corresponding angles postulate for my reason because I knew that the lines were parallel. The reason I knew the angles were congruent is because the lines were parallel. That's why I was allowed to use the corresponding angles. If I didn't know that the lines were parallel, I wouldn't be able to use that. My next given was angle BFE is congruent to JBD. I can't do anything with a congruent statement. So now what I'm going to look for next is something to connect my statement 1 and my statement 2. If I'm looking at those statements, they both have angle JBD in common. And I did that intentionally because remember, I want to try to connect the statements. If angle BFE is congruent to JBD and angle CJK is congruent to JBD, then angle CJK is congruent to angle BFE, and that is the transitive property. I have 2 angles that are congruent to the same angle, therefore they're congruent to each other. I'm going to put that in my diagram. Actually, it's already there. So this angle is congruent to this angle. Now check out your diagram. This is why it's important to make sure you're putting your tick marks in there. I can clearly see that this angle and this angle are corresponding angles. This CJK and BFE are corresponding angles and they're congruent, which means that these lines that they are touching have to be parallel. MK, and make sure you get your notation there, is parallel to GE. How did I know that? Well, that was the converse of the corresponding angles postulate. And there you go. 2 proofs to practice proving that lines are parallel. If you learned something, please like and subscribe and stay tuned for more videos.